Hey guys, today we're going to start our Unit 2 and we're going to talk about inductive reasoning. Okay, so we're going to start off with just finding a few patterns. Okay, so the example number 1 says find the next item in the pattern. It says January, March, May, and you'll notice that you skip a month every time. January, skip February, March, skip April, get to May. Then after May you would skip June and you would get July for your next one in the pattern. Okay? Example number 2, we're just going to keep finding these patterns. These are easy. We got 7, 14, 21, 28. You'll notice that every one goes up 7. Okay, so after 28, you're going to do another one that goes up 7, and that will give you 35. Okay? Example number 3. You're finding the next item in the pattern, which way the triangle goes. It looks like it's moving in this direction or counterclockwise. Okay, so your next one would go like this. Okay? You're just moving that point 90 degrees every time. Okay? And example number 4, you're just adding an additional 0 on every single time. Or you're just moving your decimal place over to the left one more time. So this time we'll just move it one more to the left, so you would have 0.0004. Okay, 0.0004. Alright, what inductive reasoning is what we're talking about today? Write this down. Inductive reasoning is determining can't even spell it, determining that a rule or a statement is true because specific cases are true. Okay, so it says determining that a rule or statement is true because specific cases are true. Okay, so let's look at a couple of examples. And it says complete the conjecture. And just know that a conjecture is a statement that you believe to be true based on inductive reasoning. Okay, so if you have any reason to believe something, that would be a conjecture. Okay, so it says the sum of two positive numbers is, let's look at some examples. Two positive numbers. 1 plus 1 would equal 2. 25 plus 4 equals 29. And what happens every time? Okay, your answer is always going to be positive. So your answer is positive. Okay, so our conjecture would be that our answer is going to be positive. Okay, let's look at example number 6. It says the number of lines formed by 4 points, no 3 which are collinear. Okay, so let's draw 4 points. Got 1, 2, 3, 4. And you can form 6 different lines, I believe. Okay, 1, 2, 3, 4, 5, and 6. Okay, those 6 lines would be the ones that you could form using 4 points and none of them being collinear or 3 on the same line. Okay? Kind of moving fast through this. Let's keep moving. Okay, the product of two odd numbers. Okay, odd numbers 1, 3, 5, 7, 9, those guys, and product meaning multiplication. Okay, so we'd have 1, let's do an example. 1 times 1 would equal 1. 3 times 3 equals 9. 5 times 7 is 35. Okay, and what is the product? What happens every time? You have 1, 9, and 35. What is common amongst those? Well, of course, you have odd numbers, so your answer is going to be odd when you multiply two odd numbers together. Okay, go ahead and take a look at the next page real quick. Okay, a couple things you need to look for when you are using inductive reasoning. Number one, look for a pattern. Okay, you always want to look for patterns when you're doing math. Number two, you're going to make a conjecture or a hypothesis. Just an educated guess, basically. And number three, you're going to prove the conjecture or find a counterexample. Okay, what a counterexample is just something that makes that conjecture not true. Okay, so make sure you got all those things written down. We're going to go through a couple of examples. And it says, show that the conjecture is false by finding a counterexample. And it says, for every integer n cubed is positive. So what this is saying, or this conjecture is saying, is that no matter what number you put in for n, it's always going to be positive. Okay, so let's try a couple. We got 1 cubed. Let's just put a number in there. Okay, 1 times 1 times 1 is going to be 1. So far, the conjecture holds true. That is a positive number. Let's try a negative number. Let's try negative 2 cubed. Okay, so negative 2 cubed. That is negative 2 times negative 2 times negative 2. And that happens to give you negative 8. Oops. Negative 8. And we know that, of course, is not a positive number. So negative 2 would be a counterexample for that conjecture. Okay, let's go through a couple more examples. Okay, number 9 says, show that the conjecture is false by finding a counterexample. It says, two complementary angles are not congruent. Okay, two complementary angles are not congruent. Okay, remember, two angles that are complementary add up to 90. They have to add up to 90. And it says that you cannot come up with two that are the same that add up to 90. Well, of course, we know that you can add up 45-degree angle and another 45-degree angle, and that equals 90. So they add up to 90, so they're complementary. And they're also congruent because they're the same angle. So you're just wanting to find a counterexample that makes the conjecture not true. Okay, let's look at number 10. Two more. So show the conjecture is false by finding a counterexample. Okay, and it says for any real number x and x squared is greater than or equal to x. Okay, so let's just try a couple. We're going to let x equal 1/2, for example. Okay, so 1/2, let's throw that in there. And let's square it. Okay, and 1/2 squared, 1/2 times 1/2 gives you 1/4. And 1/4 is not greater than 1/2. So I threw 1/2 into this x squared guy. And if you compare it to, after you square it, you get 1/4, and that is not greater than 1/2. So this is not true. Okay, so we have found a counterexample by plugging in 1/2. Okay, I'm moving kind of quick. You're going to have to follow along with me. Okay, example number 11, last one. It says, show that the conjecture is false by finding a counterexample. And it says supplementary angles are adjacent. Okay, what it means by supplementary is it has two angles that add up to 180. And what it means by adjacent is that they have to have a common vertex and they have to share a side. Okay, so let's come up with an example that counters that. Okay, so for example, we have an angle that's 23 degrees. and we have another that's 157. Okay, we know that these are supplementary angles because 23 plus 157 is 180, but they don't share a common vertex and they don't share a common side, so we know that these are not, or this is not an adjacent angle. Okay? Hopefully you guys took something from this. Make sure you go back and re-watch if you need to, and then go ahead and get started on your Google form. See ya.